given a rational function f(x), we are to express it in partial fractions. Look at the denominator. There is a linear factor 1 minus x, and 2 plus 3x is a repeated linear factors. So we can write 8 plus 5x plus 12x squared over 1 minus x, 2 plus 3x squared. We can decompose this into 1a over 1 minus x. Since the denominator is linear, the numerator must be a constant, and the second term, we have b over 2 plus 3x, and the last one, we have 2 plus 3x squared. This is a repeated linear factor, so the numerator must be a constant. Now we make a common denominator on the right, so that a is multiplied to 2 plus 3x squared, b is multiplied to 1 minus x, and 2 plus 3x. C is multiplied to 1 minus x. All over the common denominator, which is 1 minus x, and 2 plus 3x squared. The left and the right have common denominators, so their numerator must be equivalent. We say that 8 plus 5x plus 12x squared, this is equivalent to a 2 plus 3x squared plus b 1 minus x, 2 plus 3x plus c 1 minus x. We need to find the values of a, b, and c. We can always equate coefficients, but a more efficient way is, let's look at the linear factor 1 minus x here. If you set 1 minus x to 0, x is 1. So we can let x to be 1. When we let x to be 1, b is gone because 1 minus x is 0 multiplied by b or anything else is 0. Similarly, the c term is gone. We are left with the a term. When you replace x with 1, we have 2 plus 3 times 1 is 3 squared times a. This is 8 plus 5 times 1 plus 12 times 1 squared. So we have 25a equals 25, and a is 1. We can find the other values b and c. We have another linear factor, which is 2 plus 3x. Set it to 0, and we have 3x equals negative 2. X is negative 2 over 3. Now we can let x to be negative 2 over 3. Any term that contains 2 plus 3x is 0. A is gone, b is gone. Then we can find the value of c. We have 1 minus negative 2 over 3 times c equals 8 plus 5 times negative 2 over 3 plus 12 times negative 2 over 3 squared. That is 1 plus 2 over 3, which gives 5 over 3c. So on the left here, we have, on the right, sorry, we have 8 minus 10 over 3 plus 12 times 4 over 9. Can evaluate the right side directly. And let's just clear this. We have 5 over 3c on the left. And when you evaluate the right side, you get a value of 10. From here, C must be 6. That gives us the value of C. We have A and C. We need to find the value of B. It's easier to equate coefficients now. Let's look at this. B has coefficient of x squared. C doesn't have coefficient of x squared, and A has coefficient of x squared. So if you look at this A here, you have 4 plus 12x plus 9x squared. And then if you look at B here, you have something, and then we have minus 3x squared. So we only need to look at the coefficient of x squared to find the value of B. You can of course substitute any value into x, but that is just too troublesome. We equate the coefficients of x squared. Let's see. Over here, the coefficient of x squared is 9a. The coefficient of x squared for the second term here is negative 3b. And on the left, the coefficient of x squared is 12. Rearranging, we have 3b equals 9a minus 12. Since a is 1, 3b is 9 minus 12. So B here is negative 1. Fx can now be written as A is 1. So we have 1 over 1 minus x. B is negative 1. We have negative 1 over 2 plus 3x. And C is 6. We have 6 over the square of 2 plus 3x. Therefore, we have expressed fx in partial fractions. Part B, we need to obtain the expansion of fx in ascending powers of x up to and including the term in x squared. Let's rewrite fx again. So this is 1 over 1 minus x minus 1 over 2 plus 3x. And we have 6 over 2 plus 3x squared. Okay, let's see. We need to expand this using the general binomial theorem. The first term, we have 1 minus x to the negative 1. The second term, you have 2 plus 3x to the negative 1 plus 6. The third term is 2 plus 3x to the negative 2. So we need to expand all these three. We could expand them one by one. Let's look at 1 minus x to the negative 1. Using the general binomial expansion formula, we have 1, n is negative 1 plus nx. So we have negative 1, negative x plus negative 1, negative 2 over 2 factorial negative x squared. That is 1 plus x. This is 2 over 2 factorial is 1. Then we have x squared. So that is 1 minus x to the negative 1, which we will need later. The second term that we have, forget about the negative sign, we'll deal with that later. We have 2 plus 3x to the negative 1. Now the first term must be 1, so we can write this as 2, 1 plus 3 over 2x to the negative 1. We factor out the 2 from this part. Then we have 2 to the negative 1, which is 1 over 2. And we have 1 plus 3 over 2x to the negative 1. We expand this part using the general binomial theorem. So yeah, 1 plus negative 1. Then we have 3 over 2x plus negative 1, negative 2 over 2 factorial, and 3 over 2x squared. That is 1/2. Then we have 1 minus 3 over 2x. That's this part here is just a 1, and we have 9 over 4x squared. Plus minus, this one should be a minus sign. And then distribute the 1/2, expand the 1/2, bring it in, so that we have 1 over 2 minus 3 over 4x plus 9 over 8x squared. So negative 1, negative 2 over 2 factorial. Then we have 9 over 4, 9 over 8 x squared, and this is negative. The third term that we have is 2 plus 3x to the negative 2. For the third term, let's just work on it here. 2 plus 3x to the negative 2. So we can factor out a 2, and we have 1 plus 3 over 2x to the negative 2. So 2 to the negative 2 is 1 over 2 to the 2, which is 1 over 4. We have 1 over 4, and 1 plus 3 over 2x to the negative 2. We expand this part. That would be 1 plus negative 2 times 3 over 2x plus negative 2, negative 3 over 2 factorial, and 3 over 2x squared. So that is 1 over 4. Negative 2 times 3 over 2 is just a negative 3. And that part here is 6 over 2 factorial. That is 6 over 2, which is 3. And this part is 9 over 4x squared. 3 times 9 will give us 27. So we have 27 over 4x squared. Multiply the 1/4 in, so that will give us 1 over 4 minus 3 over 4x plus 27 over 16 x squared. And that would be a minus sign. It doesn't really matter here. Now, fx we must replace all these 3 into the fx term, so that fx now, for this first part, we replace it with, for the first partial fraction, we replace it with 1 plus x squared minus the second term. We have 1 over 2 minus 3 over 4x plus 9 over 8x squared. And for the third term, do not forget the 6 here. And we have 1 over 4 minus 3 over 4x plus 27 over 16x squared, which we can just expand everything 1 minus x plus x squared. Forget about this, we can group them together. Minus 1/2 plus 3 over 4x minus 9 over 8x squared. 6 over 4 is 3 over 2 minus 3 over 4 times 6. That will give us that is 39 over 2x. And then we add to 81 over 8x squared and the rest. We can collect like terms now. That will give us 2 minus 11 over 4x plus 10x squared. So that will give us the binomial expansion up to and including the term in x squared.